Hello everyone, welcome back to my YouTube channel. I am Nishchita SN, 4th SEM BE, Department of Electronics and Communication Engineering in Sri Venkateshwara College of Engineering, Bangalore. In this video, I am going to discuss about the subject microcontroller. In that, the topic is about data transfer instruction, move data between registers, memory locations and the accumulator. First, we know about introduction to data transfer instruction. Data transfer instructions are fundamental commands in computer architecture that enable the movement of data between register, memory, and input or output devices. These instructions form the backbone of program execution, facilitating the flow of information required for a system to function efficiently. Efficiently data between systems is a critical skill in today's digital landscape. In this presentation, we will explore best practices and tools for seamless data transfer to empower your organization's data-driven decision making. Types of data transfer instruction. First one is move instruction, second one is load instruction, third one is store instruction, fourth one is push and pop instruction. First we know about the definition of the move instruction. The move instruction directly transfer data between two registers or between a register and a memory. It's the most basic data transfer operation allowing you to copy values without modifying them. Second one is load instruction. The load instruction retrieves data from memory and stores it in a register. This allows the processor to access and manipulate data that is stored in a system memory. Third one is store instruction. The store instruction writes the content of a register to a memory location. This enables the processor to save computed result or other data for later use. Fourth one is push and pop instructions. The push instructions stores a value from a register onto the stack, while the pop instruction retrieves a value from the stack and stores it in a register. These are essential for managing function call state. First, we know about move instruction. The move instruction is a fundamental data transfer operation in computer architecture. It allows you to copy the contents of one register to another efficiently, moving data between registers. This simple yet powerful instruction forms the basis for many other more complex data manipulations and calculations in a computer program. Second one is load instruction. The load instruction is a fundamental operation in the computer architecture that retrieves data from memory and loads it into a processor register. This allows the CPU to access and operate on the loaded data efficiently. Load instructions specify the source memory addresses and the destination register. They enable the processor to read value from RAM or other memory locations and transfer them into internal register for further processing. Third one is store instruction. In that, the first one is storing data. The store instruction copies the contents of a source register to a specified memory location, allowing data to be saved for later retrieval. Second one is memory access. Store instruction require an address to specify wherein memory and data should be written. These addresses can come from register or be calculated based on the instruction. Third one is efficient data. Proper use of store instruction is crucial for optimizing data transfer performance by minimizing unnecessary memory access and register to register copying. Last is push instruction. The push instruction is used to store data from a register or memory location onto the stack. It decrements the stack pointer and writes the data to the new top of the stack. This allows for efficient storage and retrieval of values, enabling functions to save and store their state. Pop instruction. The pop instruction is used to retrieve data from the stack and store it in a register or memory location. This is the reverse operation of the push instruction, which adds data to the stack. The pop instruction is commonly used to restore register values that were saved on the stack, such as when returning from a function call. It allows efficient management of the program's execution state. Next is register. The definition of the register is registers are high-speed storage location within the CPU that hold data, addresses, and instruction for immediate processing. Types of registers are common registers include the accumulator, index register, instruction pointer, and general purpose register for storing temporary values. Importance of registers are register enable fast access to data and instructions, allowing the CPU to perform computation and manage program execution efficiently. Next is memory location. In that there are three types: random access memory, that is RAM. Second one is hard disk drive, that is HDD. Third one is solid state drive, that is SSD. RAM, first one is RAM. RAM is the primary memory in a computer system, allowing rapid access to data and instruction for the processor. It temporarily stores the programs and data being used by the CPU. Second one is hard disk drive. HDDs are non-volatile storage devices that permanently store large amount of data, programs, and the computer operating system. They provide long-term retentions of information even when the power is turned off. Last one is solid state drive. SSDs are a newer form of storage that use flash memory chips instead of spinning platters. They offer faster data access times and are more durable than traditional HDDs. Next is accumulator. First we know about what is accumulator. The accumulator is a special purpose register in a computer CPU that stores the results of arithmetic and logic operations. Transferring data. Data can be transferred to the form and the accumulator enable calculation and move result to other parts of the computer memory. Next is central processing. The accumulator is central to the CPU's ability to process information, serving as a temporary storage location for intermediate result. First, we know about the transferring data between register. First one is load is transfer. Copy data from one register to another. Next transfer is move. Transfer data between two registers. Next one is exchange. Swap contents of two registers. Registers are high-speed memory location directly accessible by the processor, arithmetic and logic unit. Transferring data between registers is a fundamental operation in a computer system, allowing the processor to efficiently manipulate and process information. This includes loading data from one register to another, moving data between registers, and exchanging the contents of two registers. Next one is transferring data between memory locations. First one is load data. The CPU can load data from a specific memory location into a register for processing. Second one is store data. After processing, the CPU can store the data back to a different memory location for later use. Third one is memory addressing. The CPU uses memory addresses to precisely identify the source and destination's memory location for data transfer. Next one is transferring data between registers and memory. In that, the first one is load, transfer data from memory to a register. Second one is store, transfer data from a register to a memory. Third one is move, transfer data between two registers. Data transfer instruction allows the CPU to move data between register and memory locations. The load instruction copies data from memory addresses into a register, while the store instruction copies data from a register into a memory addresses. The move instruction transfers data directly between two registers without going through memory. La transferring data between registers and accumulator. Move to accumulator. Copy the content of register into the accumulator, enabling further processing or storage of the data. Second one is copying from accumulator. Transfer the value stored in the accumulator back into a register, making it available for subsequent operation. Third one is exchange values. Swap the contents of registers and the accumulator, allowing for efficient data shuffling between the two. In last one is transferring data between memory and accumulator. Load from memory. Copy data from memory location to the accumulator. Store to memory. Copy data from accumulator to memory location. Exchange with memory. Swap the contents of the accumulator and a memory location. Data transfer instruction provides a crucial link between the computer memory and its arithmetic logic unit, which is presented by the accumulator register. By moving data between two memory and the accumulator, programs can access and manipulate the necessary information to perform computation and carry out program logic. Thank you for watching this video.